Good morning. My name is Susan Labadorf, and today I will be discussing 3 areas of avian research. Let's begin with the American woodcock. This section summarizes a large-scale cooperative research project, the Eastern Woodcock Migration Research Cooperative, that leveraged satellite telemetry to revolutionize our understanding of the species migration. The woodcock is an anomaly. Taxonomically, it is related to sandpipers and plovers. It's a shore bird, yet it evolved to live exclusively in upland forest. They are endemic to the eastern half of North America and are habitat specialists, requiring young, recently disturbed forests. They also are dietary specialists, with earthworms making up to 90 or 95% of their diet. For decades, woodcock management has been divided into 2 distinct administrative units by the U.S. Fish and Wildlife Service. The Central Management Region, which is west of the Appalachians, and the Eastern Management Region, which is east of the mountains toward the Atlantic. The Appalachian Mountains were viewed as a dividing line separating 2 populations. Management decisions, such as hunting regulations, rely on this 2-region model. One of the questions posed by this research is the district system an accurate reflection of the 2 woodcock population? The short answer is yes. The regions do differ. Recent investigations suggest that while boundaries are not impermeable walls, they are biologically relevant and reflect a genuine split in the population structure. This is what this research endeavored to understand. Historically, we have been very limited in our ability to gather data about migration. Environmental clues, bird banding, VHF, radiotelemetry are all limited in the amount of information they provide. But now we can utilize GPS transmitters coupled with Argos satellite uplinks. This allows for continuous high-resolution data across the entire continent, regardless of the terrain. So what does a woodcock migration look like? The data reveal that during fall migration, the average journey is about 900 miles, though it can reach 1,600 miles. It takes the average bird 25 days to complete this trip, making 4 to 5 stopovers. They stop to rest and refuel for an average of 5 days at a time. And when they do fly, they cover about 160 miles in a single night. There was even one bird that covered 630 miles in a single night, likely aided by strong tailwinds. When the woodcocks migrate, 70% of the birds marked in the Eastern Management Region never leave it during their entire life cycle. This strongly supports the current management model. While roughly 30% of eastern birds do cross the boundary into the central region, they mostly do so as a temporary stopover during migration or drift during the winter. Only about 4% of the birds actually switch their breeding region. Because breeding populations remain largely distinct, we can say that the management units are valid. This study also uncovered the phenology or timing of migration. They found 3 key drivers. Number 1 is latitude. Departure is delayed by about 4 days for every degree of latitude you move south. Number 2 is age. Adults depart about 5 days earlier than young of the year birds. Number 3 and 4 are sex and conditions. Males leave earlier in the spring, about 6 days ahead of females, to establish their territories. Males in better physical condition leave earlier, but females in better condition wait until later. I'd like to shift my focus now to the habitat these birds rely on, specifically the long-term effects of mountaintop removing and coal mining on Appalachian forest. This section analyzes a study on avian response to reclaimed mines, similar to the work by Becker et al. In 2015, which quantified avian community thresholds in these landscapes. Originally, the mountains of West Virginia were covered with mature red spruce and northern hardwood ecosystems, areas naturally dominated by interior forest guilds and with high biodiversity. Now the mountaintops have been cut off and the landscapes fundamentally altered. Mountaintop removing and valley filling converts forest to surface mines, burying streams and fragmenting the remaining forest. The process of surface mining fundamentally alters the landscape, removing the established forest and its complex soil structure. How does this alteration affect bird communities? Do the forests naturally regenerate, or do they need intervention to come back? In evaluating the use of reclaimed forests by threatened, endangered, and species of concern on Appalachian coal mines, 2024, Price et al., they evaluate how avian communities respond to 3 different types of landscape. Number 1, unmined mature forest, which serves as a control. Number 2, naturally regenerated forest mines, old sites left to regenerate naturally. And number 3, forest reclamation approach, or FRA sites with purposeful intervention to restore forest in the area. This comparison highlights 2 divergent paths for restoration. The passive path, which is natural regeneration, was standard for decades. These legacy sites often suffer from quote-unquote arrested succession due to soil compaction and competition from invasive species. The active path is the forestry reclamation approach. This is a science-based method involving proper soil preparation and the intentional planting of native trees to jumpstart the ecosystem recovery. The data on passive regeneration is stark. Even after 40 years, many naturally regenerated legacy sites remain as grasslands or shrublands dominated by exotic species. Critically, studies have shown that while these areas might support some grassland birds, they fail to regenerate a forest and support the forest interior guilds that originally inhabited the area. The loss of core forest leads to significant declines in forest interior guilds. This is noted by Becker et al., where negative responses occurred at just 4% forest loss. In contrast, the FRA sites, especially those 2 to 11 years post-reclamation show a very different trajectory. The Price et al. Study found a high positive association between FRA sites and the young forest bird guild. By loosening the soil and planting natives, they essentially fast-forward the ecosystem into a functional early successional habitat. This mirrors findings that early successional guilds respond positively to the creation of shrubland habitats in mining landscapes. Unfortunately, the forests established by the FRA did not have many mature forest guild birds. As the forest age, these guilds begin to return. This suggests that there is hope for restoration, at least as far as the birds are concerned. The results are clear. Active management via the forest reclamation approach puts mined lands on a faster, more effective path to recovery than natural regeneration. In this final section, I want to talk about 9 pollutants and their effects on birds. The first of the 9 is artificial light at night. This acts as a sensory pollutant. It disrupts circadian rhythms, causing birds to sing earlier in the morning and extending their activity into the night. Many birds migrate at night. Light can disorient nocturnal migrants. Noise pollution is also a problem. When I was trying to do birding near a road, traffic often interfered with bird songs. Noise creates acoustic masking, interfering with communication. It forces birds to alter the frequency of their calls to be heard or to abandon the suitable habitat entirely. Chronic noise exposure has been linked to reduced reproductive success and increasing stress hormone levels in nestlings. Air pollution. Birds have highly efficient respiratory systems, which ironically makes them more susceptible to airborne toxins. Pollutants like particulate matter, ozone, and heavy metals in the air can cause respiratory distress. Heavy metal accumulation, specifically lead, mercury, arsenic, cadmium, and others, are severe and multifaceted. The core problem is that heavy metals bioaccumulate in the tissues and biomagnify through the food web, meaning that apex predators and scavengers often suffer the highest concentrations and most severe effects, including direct death, high concentrations of lead, often ingested as spent ammunition or fishing weights, which birds mistake for food, can lead to lead poisoning and secondary poisoning. Predators and scavengers like vultures and condors are susceptible to secondary poisoning by ingesting prey contaminated with lead shot or high mercury levels. Radiation. While less common, incidents like Chernobyl and Fukushima have shown us the impacts of ionizing radiation. Effects range from direct DNA damage and reduced brain size to sperm abnormalities. Perhaps the most widespread chemical threat is pesticides. There are 4 main types. There are insecticides, compounds like neonicotinoids that are neurotoxins and can cause weight loss. Herbicides, chemicals that kill plants, and the plant base supports arthropods birds feed on, reducing food availability. Fungicides These can act as endocrine disruptors, inhibiting steroid biosynthesis and impairing reproduction. And rodenticides, these cause secondary poisoning. Raptors eat poisoned rodents, leading to internal hemorrhaging and death. Pharmaceuticals affect birds in major ways. First is direct toxicity, famously seen in the Asian vulture crisis, where vultures consumed animals that had diclofenac in their systems, causing the vultures to have kidney failure and wiping out 99% of vulture populations. Secondly, even non-lethal doses can alter critical behaviors. Antidepressants entering the waterways have been shown to reduce feeding effort in wild starlings. Oil destroys the waterproofing structure of the feathers, leading to hypothermia and flight impairment. Plastic. Seabirds mistake plastic for prey, leading to physical blockages in the gut and false satiation. Furthermore, plastics absorb toxins from the water, which can then leach into the bird's bloodstream. With all these pollutants, it's hard to pick out the most important one, but I think that personally I would say that plastic is the worst pollutant for the following reasons. The volume is huge. Almost every continent is plagued with this problem. It floats in our oceans and it ends up in what we were hoping to be pristine environments. Birds ingest it and get tangled in it. Number 2, plastic is long-lived. Even if we stopped using plastic today, we would be dealing with it for years. I think that the most surprising pollutant that I found while taking this course was the effect of light on migrating birds. I did not realize it could actually throw off their migration. I think that covers everything. Thanks, and have a good evening.